Let's get hyped for Tiger Beetle. Let's get hyped for Rust. Let's also get hyped for Zig. Hi, my name is Brian, and I'm here to hack on Tiger Beetle. So, this is a project that we're doing on stream to create a Rust client for Tiger Beetle database. Tiger Beetle, of course, is a high-performance financial database written in Zig. It's got clients for all the usual suspects of languages you might want to write in, but no Rust. So this is a project to create a Rust client. Give me 1 second here. Too hot in the cans. So this project we've been doing for several months, and it is a project to create a client for Tiger Beetle. All the Tiger Beetle clients currently are bindings to a library called TB client, written in Zig, and that is also true for the Rust client. This Rust client is async Rust. It presents an async interface, non-blocking, and most of the work, though, is done by Zig. In the future, we might do a pure Rust client, but that is, future work. So we've been doing this project for a while, and it's at the point now where we have submitted a PR, an initial PR, to get some feedback, and we got a bunch of good feedback, and we're doing some rework to get that PR pushed through. Last time we were working on creating a custom Rust binding generator specifically for Tiger Beetle, because all of the Tiger Beetle clients, they have a little Zig bindings generator written in Zig that spits out code appropriate to create, Go, Rust, Java bindings for the TB client library. And we started this project using BindGen, the Rust bindings generator. But at this point, we want to actually, stick to the pattern that we've already established with the other generators and just have our own little custom in-house generator. So that's what we've been working on. And as I recall, in the last stream, we got that work mostly done, but it was a few little things left to do. And it's been like 2 weeks now since we worked on that, so I've kind of forgotten everything. So this stream is just kind of be getting back into the swing of it. Figure out where we were, hopefully push that work through. I feel like I'm coming down with a little bit of a cold today, so we'll see how this goes. We might not last too long on stream. I'm feeling a little froggy here. This might be a stream where you get to watch a lot of sneezing and blowing my nose. I'll try to remember to switch off the cam for that. We'll see. Anyway, let's go just kind of refresh where we were. The first thing I'm going to do is just go to the code, do some, maintenance, git pulls and things like that. All right, so here's our workspace. I'm going to git fetch. I'm just going to fetch the entire world. This repo doesn't seem to exist anymore. I'm going to remove it. Git remote rm wpaulino. Okay, that looks all right. And you can see our history here is just a bunch of little temporary commits. So I don't really know where we are. I can go ahead and squash this and kind of do a diff. Wow, look at all that work we did. So this, all right, let's back up real quick. Say git status. Remember, we're on a branch called Rust client bind work. So our PR is for Rust client. And this bindings rework is, big enough that I created another branch just to do that rework for the bindings. And so here's kind of what our reviewer is seeing. And then all this other history above that is, what we're doing. So I can just squash onto Rust client right here. And then we can do a diff of that and, refresh ourselves on what we were doing last time. Ooh. Oh, I'm feeling it, chat. I got the itches in the throat, and I got a chill going on here. Okay, we're gonna squash onto Rust client, and our workspace is clean here. I'm gonna say git rebase. Actually, I'm just gonna check out git reset person Rust client, but not hard. So I'm just gonna leave all of the changes in the tree. And I'm going to add everything. See, the only new file we've added here is this rustbindings.zig. That is our new bindings generator. I'm just going to re-add everything and create, let's see, I'm in the wrong directory here. I need to back up a little. I'm going to re-add everything. And now I just have one commit that has all of this work on it. Let's go back into our Rust client directory. And now I can do a diff here. First do a git diff stat. You can see this is all should be work on the Rust bindings generator. So we had to add a little bit to the build.zig. This is the Tiger Beetle build script. This is to build this Zig bindings generator. So we might do a little bit of Zig programming on stream today, but most of our Zig programming for this is probably behind us at this point. This stream is going to be just kind of a lot of little administrative things today, probably. Git ignore, we probably ignored whatever the output of this is, which is a file called tbclient. You can't see it in the diff because it's ignored. tbclient.rs is what's output by Rust bindings. And we changed our Rust build script here for some reason. And we changed the Rust library here for some reason. Don't recall. All right, let's look at the full diff. Git diff head caret. All right, so here's our build script. This is not going to be super interesting, but here's some Zig code. So we have a build target called clients Rust, and this is what that does. It calls build client, build Rust client, with some options that I mostly don't remember. And this code was mostly copied from probably the Go bindings builder. But we have a bindings generator. This is an executable. I add executable here. The way Zig's build scripts works is just kind of a toolkit for kind of creating a mostly declarative, build plan, like a graph of what needs to happen in your build, and then you pass it off to the standard library, and it just runs the whole build script for you. But I mean, I say declarative, but this is all imperative code to build this declarative graph. And I assume it's mostly declarative, but maybe it's not completely declarative. Anyway, I find this a little bit awkward the way the build script works because it's writing so much imperative code. Anyway, that's beside the point. So we have building an executable here, and these are just like dependencies, Zig dependencies it needs. And then we declare a generated file called tbclient2. So remember, in this process, we've been replacing one bindings generator with another bindings generator. So the output of our first bindings generator is tbclient, and the output of the new one is tbclient2. And so apparently last time we didn't get to the point where we were able to actually replace the first generator. Okay, this is all Straightforward. You can see there's our get ignore where we ignore two different bindings. So no Siam in chat says that Zig actually runs the build script on a WASM VM. That's very interesting and very progressive. One of the problems with a lot of build systems is they aren't completely declarative and aren't completely reproducible. But if you kind of encapsulate them all in a VM and just run that same VM everywhere, that solves some of those problems. Like one of the long-standing problems with Cargo and Rust is Cargo is mostly declarative, but then build scripts are just, anything goes. So one of the long-standing proposals to improve that situation is to run Rust build scripts in WASM. And it sounds like, right, apparently it's not true that the Zig build is actually running WASM right now. I know Zig uses WASM for its bootstrapping, which is very cool. Like Zig is completely bootstrapped, I think, by cross-compiling Zig to C and then compiling C to WASM. Correct me if I'm slightly wrong about that, chat. But that is very cool because Rust is not fully bootstrapped. You cannot actually build Rust without Rust. I mentioned I was a little sick before. I'm running out of breath just talking right now. This might be a fairly quiet stream. Okay, anyway, reviewing what we did here. Here's our build script. And what is this? This is the Rust build script. And this is invoking. Okay, so the Rust build script, the way you have this set up is there's kind of like a Ouroboros here between the Zig Tiger Beetle build script and the Rust build script. That's not actually true. Right now, the Rust build script will drive the Tiger Beetle build script in order to generate bindings. The Tiger Beetle build script doesn't currently attempt to build the Rust. And here's our new bindings generator written in Zig. And fortunately, last time I had the foresight to leave myself a breadcrumb trail of notes here. That's going to be very helpful. And this code is all the code we wrote last time, mostly copied from the C bindings generator. And then, yeah, you can see right here, I remember last time we worked on this, I was attempting to replace the old bindings with the new bindings, and we ran into some kind of problem that I don't remember. Okay, mostly refreshed there. Let's go real quick and go look at the webs. And I noticed some notifications in my mailbox on the PR we're working on, so I want to go see if anybody's said anything. And also, there's another issue that impacts our work here that we need to go just have an eyeball scan of real quick. All right, so here's our PR. And let's see if anybody has said anything new recently. Okay, so one of the things I mentioned previously when we went through the first pass of this PR, or first pass of the review, was our reviewer, Matt Cladd, who is a genius, was talking about what we're going to need to do when we deploy to crates.io. And our plan right now is to just build all of these Zig dependencies and package them into the crate, which is sometimes done in Rust crates. It works if you are smart about how you build those dependencies. And fortunately, we have our dependencies are written in Zig, and we can easily just cross-compile all of our dependencies for all the platforms we support all at once. And this discussion here was about whether we use dynamic libraries or standard libraries, static libraries. And Matt Cladd agrees with me we should use a static library, so I'm giving him a little heart. Things we should avoid any conversions. Okay, yeah, this is not new. I'm just seeing if there's anything new here. 2 days ago. Are you looking to fix this? What is this? Okay, there's several new things here. So I guess we needed to discuss this as well. The code that I wrote doesn't expose all the underlying C types to the Rust API on the theory that I would rather expose Rust types to Rust APIs, not C types. But that is seemingly a little against Tiger style, where the representation is important. And so Matclad is asking to just, expose those C types all the way up. And he's asking a question here like, do I plan to do that in this PR? And I'm just going to say, yep. In general, on this project, I'm just saying, yep. Let's see what else he said. That's interesting that he came back and did like another round of review, even though I didn't really prompt him to. He probably saw that I was like spending weeks and weeks not getting this finished and decided to come back and look at it again. Exists, not necessarily an error. I think I'm not going to think very deeply about this comment right now. We've got other things to. Yeah, we've got other things to focus on right now. This is kind of getting in the weeds of minute details compared to what we're already working on. In contrast, this thing is 100% an error and should be. Okay. Just little niggles about types there. We'll come back to that some other day. Let's go do one more thing on the web before we go write some code. And there's another issue that I think has been closed that affects the TB client ABI. And it's probably going to force us to do a big rebase and some rework. And I just want to go open it up here so I have it for reference. And we'll come back to that again some other time. Let me see. I think you can filter by. No. I actually don't know how to filter things. I wanted to filter by the author because I know who wrote it, but I don't remember exactly when or what the title was. But it's Raphael Battiati. I'm just going to keep scanning through here. Output for tests. Rework the client handle. That's got to be it. Okay, I'm going to read through this, scan through this real quick, but probably not too deeply. Almost thread safe. Submit can be called for multiple application threads, dinit. Okay, so there's a use after free problem with the current API. The Rust bindings avoid that by using Rust types. We just kind of assumed that it might be problematic to have use after free and made it impossible, which is convenient that that's something the Rust type system is very good at. Guard the client handle with a mutex. Yeah, okay, so he's saying there's a other clients, not the Rust client, put a mutex around the TB client object, but the TB client object also has an internal mutex, and he's saying, that's wasteful. But we don't have a mutex around our client. We just used, basically we didn't apply a send bound to our client, so it's trapped in a thread, so you can't have, wait, that's not it. What is it here? Right. We used lifetimes on the request futures to prevent use after free. I mean, we also don't have a send bound, so our client is trapped within a single Rust thread. But also, every time you submit a request, you get a future that captures the lifetime of the client. So it's impossible to free the client while the request is outstanding. Pretty typical Rust stuff. So in this client, I remember he explained this to me over text as well, and I forgot what he actually did. API build script. Oh well. I think it doesn't matter in detail right now. Again, this is going to have to be addressed once you've addressed all the other PR information. So at the rate I'm working on this, this is going to take forever. Can't take 2 weeks between every single stream, y'all. Let's go back to the code and get some progress. All right, so first thing I'm going to do is just do a cargo check, cargo build, cargo test. Let's get the workspace primed to work. And then let's go look at our Rust bindings and read these to-dos. All right, so there's an issue with the size of the type defs of Rust structs. Those are carried over from the C bindings, but we can fix those in Rust. We've talked about that a few times, and I'll explain it again if we tackle it today. Some naming issues that are carried over from Rust bindgen that we can fix. Some dead code in the C bindings generator we noticed last time, and we may go back and try to resolve that. Not super high priority. This is probably the big thing we're missing right now. So the bindings generators at the moment, they don't actually use reflection to generate the function declarations. They just, spit out a big blob of text for functions. So we got to do that to make these bindings work. This is probably the first thing for us to do. Get those bindings working, throw away the old bindings, and then we can kind of add some polish. All right, so this all looks like it's working. We have one little smoke test and it's working. And let's open up the C bindings, which is called tvclientheader.zig. You can see down here, let me mess with my mic for a second, y'all. Okay. You can see right here, there's just this step in the generation that just spits out function declarations. So we'll do that too. And you can see there's a comment here from very long ago that said, like, we should be doing this with reflection, which is probably possible now. Someone could come back in here and fix these bindings generators to programmatically do this. But that's a yakshave for another day. All right, so we're just going to copy and paste this stuff. And unfortunately, this code is pretty awkward to edit, really, because of all these kind of new line continuations. This is a special, these double backslashes are multi-line zig syntax for strings. So what I want to try to do is just create a zig buffer over here and turn on zig. Do I have a zig mode? What is my zig mode? What mode is this buffer in? Zig, okay. Zig. Sorry, my fingers are not doing what my brain is thinking. Now we're in zig mode. And go back to the Rust bindings. I'm going to copy this into the zig buffer, and then I'm going to get rid of these. What am I thinking here? We're about to write Rust code, not zig code. Let's try this again. Let's copy over this. One buffer is zig code, but that zig code is outputting Rust code. So I'm going to take all this, and that's a disaster. Let's see if we can remember how to delete this rectangle here in Emacs. What is it? Clear rectangle? Doesn't seem right, but maybe that's right. That works. And now we should be able to just tab space to fix the indentation. And now all this C code needs to become Rust code. So we're just going to pour over this with our brains and try to remember try to imagine what the Rust definitions here look like. So this is a TB status. I'm going to go look at the Rust output so far and see if we have something called TB status. So again, this is the generated code that we're creating right now. Interesting, there's an extra space right here. I'm not sure if that is on purpose or not. TB status, okay, we do have a type called TB status. And this is going to say, all these TB statuses are going to use Rust syntax. We might as well say fun TB status. And these are also going to have to be, I'm probably going to like fix the basic shape of this function declaration and then just go do the same thing for all the functions and then go work on the individual argument syntax. This is going to be a extern C function. And this might also have to be declared unsafe. I don't really remember what the current state of externs and unsafes is right now. And in Rust 2024, there's a few changes to where you have to write unsafe. Though this crate is not going to be for Rust 2024. But if we have to write unsafe here, the compiler will tell us. But this basically looks like Rust, except for the arguments. So I'm going to do the same thing down here. And actually, I'm trying to think. These are extern functions. These might need to be in a giant extern. Man, I'm always forgetting stuff. These might all have to be declared in a gigantic extern C block like that. We'll do that and see if the compiler likes it or not. One good thing about Rust is the compiler will tell you exactly what you did wrong with some great frequency. And I keep hitting Control S on this temporary buffer. That's out of habit. Just every few things I type, I just habitually hit Control S. But this buffer is not actually on disk, so Emacs keeps complaining. What is this? Okay, this is also similar, but it's a uint pointer. I don't, on completion context uint pointer, I am not actually sure. Right, I know that's true, Andrew. So in Rust 2024, in Rust up till now, if you have an unsafe function, like the contents of that function, everything you do in it is considered unsafe, and that's no longer true with the latest version of Rust. You have to declare it's unsafe for the caller, and the things I'm doing inside it are unsafe, two different types of unsafety. These also are going to need to be pub. And I just am not sure offhand what we're doing for this right here. But I can go look at the previous bindings and just look at TB client completion context. Oh, just a usize. That's interesting. This is probably just some handle that we're not allowed to understand what it is, some pointer-sized thing. We don't use this in our bindings anyway, but that's not Rust syntax. Usize. And I hit Control S again, and Emacs just complained. This is just a pub fun with no return type. This is a pub fun with no return type. And let's go deal with all these arguments. And actually, I kind of do want to save this. I'm kind of getting scared of losing this. So I'm just going to save this somewhere. All right, so now all these arguments have to be reversed. That's a pain in the butt. I'm wondering if I should just go, like, bindgen already gave us all these declarations right here. I can probably just copy them. Yeah, these are all probably going to be nearly identical. And you can see bindgen uncleverly just put an extern block around every single function. Yeah, I'm just going to copy paste these. And then we'll go scrutinize the types one more time and make sure there's no major changes, because some of the types in our bindings may have changed slightly. Just the naming, not really the representation. What did I just do there? And I like this, I'm fond of this. Every argument gets its own lines and formatting. TB client submit. Yeah, for whatever reason, I like tall code more than wide code. But I also don't mind wide code. I'm happy if I am fine with long lines extending past, 100 columns if it makes sense for the code on hand. That looks probably correct. So let's go back to our generator. We can just copy and paste that code over into our thing and then add the special multi-line syntax to it. Where are we going? Rust bindings. Okay, so all of this is just going to be this syntax. So I'm going to have to remember how to add that to every line. I basically forget almost every single Emacs command all the time. It's kind of a pain. Okay, all that goes there, and now we need to prefix all this with something. I don't remember how to do it, chat. Let's go to the web. Let's go to the web and ask ChatGPT will probably know. In Emacs, how do I add to multiple lines at once? String rectangle. Well, none of this looks familiar to me, so maybe I've never done this before. Okay, Control XRT backslash. Remember that. Control XRT backslash. R T R. Oh, I did Alt X. Control X R T backslash. Control X R T. Nope. Control X R. Nope. Control. My old fingers. Control X R T backslash. Another backslash. There we did it. That one's not right. That's all right though. And then hopefully a tab will just indent this correctly. Not really. Okay, well, now we can probably do another rectangle delete right here to just fix that. That's annoying. I've already forgot what the delete rectangle. Yes, there we go. Okay, that all looks formatted correctly. Now we can run this and almost certainly we will have screwed something up. But let's just see if it works. No. Format.zig. What is this not liking? Okay, just a formatting error in our zig. So remember, we have to do a build step just to build this zig formatter. Huh. Okay. Oh, this error message is not very lucid. Called from here, expected something in format.zig does not really make a lot of sense to me. I bet it's something. That's one thing that happens quite a lot with zig format string printing. The errors, occur way up the stack or way down the stack in the standard library and don't really tell you what you did wrong. We can see there's something in format where I Probably some string is incorrect. Probably need to escape a bunch of stuff because it's a format string. Like there may be some brackets in here that I didn't do correctly. But like, this error does not really tell me anything useful. I mean, it tells me something's useful. Some kind of format string problem. Some kind of format string problem somewhere. If I get a backtrace, which I probably can do, it will lead me to the this code where the error probably is. But I'm just going to try to intuit what's going on here. Probably these braces have special meaning in a Zig format string, similar to Rust. And in Rust, I would do a double brace. So let's just see if that works. Ooh, that's annoying. The Emacs Zig mode doesn't understand these multi-line strings very well. Okay, we got further. Let's see what's going on here. Okay, so I have some redeclarations here. This is almost certainly because we have two bindings being linked into our crate right now. And it's saying they don't match, which is interesting. Probably just because these types are, they read the same, but they're not literally the same types. So what I can probably do, interesting, these are just warnings, so kind of no big deal. But what we can try to do is go remove the old bindings and just see if this builds. Because our current approach is to reproduce exactly the old bindings, at least the type signatures of the old bindings, so that our new bindings are a drop-in replacement for the bind gen code. So here I'm just going to say, let's enable the new bindings and disable the old bindings. Let's see if this builds. And okay, there's some problems with visibility. Let's go to the Rust bindings, not Rust bindings, but the generated Rust bindings. And these errors are saying like tbclient.t is private. Let's just, right here. Okay, so that's a simple fix. Let's scan through here real quickly and see if there's other types of things that are not pub. So this type alias is pub, but this type alias, not pub. Let's go figure out what the distinction between those is. Rust bindings. And let's just look for the string type. Yeah, there we go. There's one. So type mappings. You can probably just guess that this is it because there is no pub here. Let's try that again. Okay, got a little further. Expected function pointer unsafe extern, and we got an extern. So our function declarations, we probably do need to add unsafe explicitly to them. As we were mentioning before, I couldn't really remember whether unsafe was the default or not. Seems like it's not. What am I doing? That is not right. Let's go back to our Rust bindings. So over here, all these functions, pub unsafe function. Let's see if that gets us there. Still not quite there. Items and extern blocks without an unsafe qualifier cannot have safety qualifier. Ah, okay. Well, Rust is telling me that I did this incorrectly. We should add the unsafe to the entire extern block. Let's try that one. Still not quite there. This error looks exactly the same, so maybe I assumed too much when I thought that would fix it. Let's see what this is here. librs52. This completion right here. So TB client init, let's go look at TB client init right here, is expecting an option of a extern function, unsafe extern function, and we have given it an extern function. What is different here? Because remember, we copied this straight from bindgen, didn't we? tbclient.rs. Here's the bindgen code again. And yeah, bindgen didn't put any unsafes anywhere here, so this was just the wrong thing to do. Let's go build that again and see. Expected function pointer. Okay, it seems, okay, here's what's going on here. Yeah. Oh man, this error message is so good. This is a little misleading, I think. I really should refresh myself on what the interaction between extern functions and unsafe is, but it seems to be indicating that I'm missing an unsafe, but I don't think that's the actual problem. But it did highlight this in magenta right here, and I just kind of glossed over it before, but this is exactly the problem. I am actually accidentally referencing two different bindings. Here we are expecting a type from the original bindings, and we're actually getting a type from the new bindings. So I'm not sure how that happened, but let's go look at that on completion. This is the third argument. And expected. I'm confused how we're getting these two modules mixed up. This TBC here is a alias of our namespace for the TB client module. But I don't see any way we're confusing these two modules. Let's just go ahead and remove the old bindings and see what compiler errors we get. So in my mind, this module is completely unused now, but that does not seem to be the case. So let's see what new compiler errors spring up if we just remove it. Okay, there's some stuff here. Yep, so there's a few cases here where I didn't use that TBC alias. Another one right there. That looks like it. Okay, we finally got to the point we have replaced the bindgen bindings with our new custom bindings. Should be a drop-in replacement. Let's run cargo test and see. Okay, we have done it. Yay. I'm just gonna checkpoint that and look in our to-dos for Rust bindings. That one is done. Checkpoint that too. And now I think we can just go ahead and remove the bindgen bindings completely. I don't think we're gonna need to reference them again. This all works now. So let's go to the manifest. And we should be able to just remove bindgen now. So now our only dependencies are bit flags and futures. Tiger style discourages dependencies. TigerBeetle itself has no dependencies, but this project is in the Rust world where dependencies are normal. But we got rid of that bindgen dependency at least. But we need to go over to our library here, remove this module, that is the bindgen generated module. And then we need to edit the build script. Everything related to bindgen we don't actually need anymore. see, is there this bindings path? Looks like that is everything. All right, let's see if that still tests. Okay, there's a little unused import there in the build script. Okay. Okay, checkpoint that worked. Last thing we need to do is rename TB client 2 to TB client. And then in our Rust bindings, this also probably calls it TB client 2. No, that's handled somewhere else, probably in the Zig build script. TB client 2. That is now just TB client. And then also our git ignore for the Rust crate doesn't need to care about TB client 2 anymore. And we can say rm source TB client 2. And if we do another build, it should work. And we will have purged bindgen from this Rust client. Ooh, I mentioned at the top of the stream that I felt like I was coming down with a cold, but maybe this work has invigorated me because I'm feeling all right. I'll probably collapse at the end of the stream. Every time I get done with one of these streams, I have to kind of go decompressed for an hour or so. It's kind of like performing a big concert on stage. Just like the adrenaline just kind of sustains you, and then you just I just kind of fall apart afterwards. What do we got here? This all looks good. All the tests passed. Yeah, I really have a newfound respect for those types of streamers who just stream all day, every day. That seems like shockingly hard work. Okay, let's go back and look at our README, or our to-dos. All right, let's do some cleanup here because there are things about our bindings that are not great. All right, this TB client 2 is no longer relevant, but TB client, refresh that. And this is our new bindings. So pack struct type defs are not the right width. I don't want to do that first. Let's bump that down. This is a problem with other bindings as well, so I don't know yet that I want to break the mold with the Rust bindings. This I really don't like. So double prefix enums. The TB account flags here. This is, for example, an enum. And the name of this is prefixed with the name of the enum. In C, this is an enum. In Rust, we don't make it an enum because we don't want to have, we don't want Rust to ever see invalid values for that enum. That would be undefined behavior. So in Rust, these are just constants. This is prefix TB account flags, TB account linked. Like this could really, there's special code to make this TB account here. There's basically prefix with a type name, then prefix with a type name again, and then finally the variant name. And as far as I can tell, this is completely redundant and just kind of ugly. So I kind of want to change it, but I'm wondering if there's, before I dive in and do that, I'm wondering if there's there must be a reason that it was done that way in the C bindings. Maybe just like preemptively avoiding potential name collisions. But I can't really imagine how that would cause a problem. It's also kind of not worth fixing. Like if this name is the same as in the C bindings, that's kind of helpful. You can kind of see them both the same way. But if we end up exposing some of these types to the rust, well, we're probably not going to expose these constants. These are not rusty at all. We would rewrap these in another enum probably. Also, these names here, these are not the Zig names. We could make these have better names, especially if we're thinking about exposing those to the Rust API. Like in Zig, this is just called account. But in the C bindings, they're called a TB account T. I'm gonna add another to-do for that. Yeah, I'm not sure if it's important that we remove these redundant names here. Honestly, I'm not sure whether any of this is worth doing. I might just like package up what we've done here and then push this and then think about these other to-dos in the context of the other suggestions or the other requests on the PR. Because some of the other requests, specifically the one about exposing the C types all the way up to the Rust API, will affect the naming of this. So if we end up exposing this to the Rust API, it will make sense to just call this account. So I might just deal with that later and leave these to-dos right here for now. And we could have a little fun and go investigate like some of these. This issue specifically seems to affect the C bindings generator. Do a little yakshave. Anyway, I think I want to package up all these changes and push those to the PR. And I'll tell the reviewer, Matt Clad, that I've, pushed another thing, but still doing the rework. Yeah. Okay, let's look at our history and make a history clean again. So we're just going to rebase everything onto Rust client. And not literally rebase, but I'm going to reset onto Rust client. I'm going to say rework. Replace bindgen with custom Rust bindings generator. And I'm going to do a quick, what I'm going to do, I'm going to run this through cargo format, Clippy, all the usual lints to hopefully make sure it's all cleaned up. Source clients Rust. So first I'm going to run cargo format. And that'll probably find stuff. No, nothing. Okay, so I'm going to run cargo Clippy. And hopefully it doesn't suggest anything. I've talked many times on stream about how I have mixed feelings about cargo Clippy. Clippy is great for surfacing idioms to new Rust programmers, but oftentimes I don't actually want to follow those suggestions. Fortunately, Clippy's fine with us for now. That's great. So let's push this to Rust client. I don't think we're going to need a force push. Person push person head Rust client. And now let's go check out Rust client and throw away our temporary branch. Set person Rust client. And we should be back. Yeah, there we are. Now let's go over to the PR and just send Matt Clad a note about what we've accomplished here. Don't need ChatGPT anymore. Um, I'm telling him that, like, what I've done is like literally just created a drop-in replacement for bindgen, but we might go back and refine it for our own purposes later. I'm pretty happy having that to that one step as a single commit. Like, this is the commit that we just 100% replace bindgen, but don't do any extras. And we can do extra stuff as other commits. Hard to talk and type at the same time. Regarding C ABI, C types. Okay. All right, at this point, chat, I don't know what I want to do next. I'm going to go back and look at our code here. So naming stuff, this dead code in the C bindings. It's just a slight weirdness in the build script. Go look at this real quick, actually. What we suspect, so we have a problem with this project in that seemingly what's happening is that every time I commit, it forces the Rust build script to rerun. And the hypothesis is that I have emitted the wrong rebuild metadata to cargo. And I have told cargo to rebuild based on the contents of the Git directory. If that's the case, that would explain it. And I'm kind of not feeling like tackling any difficult rework right now. So I'm just kind of looking at something to yakshave a bit. This struct type def not being the right width is actually kind of easy. And I might do that too. The packed struct case, we might be able to do that. Let's just go look at that real quick. And I'll explain real quick what that means. So there are some packed structs. Let's go look at the Tiger Beetle packed account filter flags. Let's look at this one. No, not that one. I want one that is not a U32, because right now we're emitting U32s for these cases, but not all of these are U32s. Transfer flags. This is a U16 packed struct. So what this is basically a set of bit fields on a U16. And in Zig, they're defined as a packed struct, where each of these is a bool. And so these end up taking up 1 bit, except for this U7 here, which is 7 bits. And this type doesn't directly translate to anything in Rust, so this turns into just a plain integer with a bunch of masks indicating which bit these fields are. And the bindings generator for C just assumes these are all U32s. And then in the client code, you have to kind of like cast to the correct size. But there's no real reason that I can see that the bindings couldn't just figure out that actually, no, this is a U16 and emit the right type for this. So I'm just kind of curious about this. It's kind of not a big deal either way, I think. I think it's not a big deal either way. And I just want to go look at the code and see if it's possible to fix that. This will be like a reflection topic within Zig that, useful for my education. So if we look at the emit enum, this emit enum function in the bindings is shared by both Zig enums and Zig packed structs. And so here there's a case for enums and there's a case for packed structs. And right here, this S is the type. And also this is the type. So this is just assuming that all enums and all pass structs are U32s. This CUint is generally a U32. It's very interesting because this is kind of just wrong. Like all these declarations in tigerbeetle.zig, they all say explicitly what integer type it is, and it's not a C integer type. So I'm wondering if there's some kind of method we can look at for on this type info or this type here in Zig that'll say the width of this type. And presumably there must be. And again, we've talked about this in previous streams, but I don't actually know the distinction between these two types, a type and an any type. Kind of a little confusing just visually. But type info has fields. This type info is any type. So maybe this type info also has a field on it that says like, what is the width of this type? Or maybe it's on this type. Kind of don't understand. Let's see, how are we using type here? Type is an enum. You get the type info of type and it's an enum. How is this at type info of type different from this any type called type info? I don't know. Type info should be stood. Can you explain more, No Siam? So in chat, No Siam is saying that this any type should be stood built-in type. This just raises even more questions, like are they the same thing? And then how is this type different from the, how is this type different from this type? Anyway, I'm going to go look at the Zig docs and try to see if I can figure out which one of these types includes the width of the type. And we're really yakshaving here, so let's go to Ziglang documentation, and we might need both the reference docs and the standard library docs. So first I'm going to go just look at type and any type. Good thing about the Zig language reference is all on one page, although the word type is not really going to help me find anything. I'm sure the word type appears 1,000 times. That's not great. Maybe I can find it over here in the sidebar. What is the type? Show me the type. Casting doesn't seem like it. Comp time maybe. Maybe the at type info. When you do a at type info of t, you get standard built-in type. So maybe I don't even need that other argument. If I have the well, this is very hard to find the documentation for the type. Primitive types. Is type a primitive type? Probably not. It is a primitive type. The type of types. The type of types. And is there an any type here? So remember, we had two seemingly primitive types in this function, a type type and an any type. And I see, oh, this is not clickable. Ah, help. Here's at type. String literals, primitive values. Somewhere in here, it's going to explain the type. No, this is not going to explain the type. Okay, here's the at type intrinsic. So if you give it a std built, if you call at type on std built-in type, okay, I'm kind of getting to the point where I am feeling like I'm just going to embarrass myself if I try to understand all this on stream. It feels very circular. You call the at type intrinsic on a std built-in type, and you get a type primitive type. The inverse of type info. So type info is going to give you a std built-in type. No, Siam, I really appreciate you trying to help me here. Type info, type name, type of. Call type info, you get a std built-in type. You call at type and you get a type. Reifies type information into a type. So type is just a generic type. It looks like to me type is some type, but there's also an any type, which also sounds like some type. So this is just some type, and you can get the type info for that type. Let's go look at that std built-in type, which I have previously hypothesized was any type, just aliases for each other. Nothing obviously claiming that here. And the documentation is pretty lacking here. But this std built-in type is kind of like the type information for a type. Lib std building.zig, it's on the stem. You can see if you go to, I'm reading chat, go to lib std built-in.zig, it's on the std lib. Let's see if we can just open this and that'll bring us right there. Yep, right there. Built in. So somewhere here is a type called type. Yep, and this all looks like type info. Calling conventions. All right, so here is type, std built-in type right here. This is a union. This is a union. It's a union enum. Does that mean each of these fields is overlapping? I think that must be what that means. Like you can only access one of these at once as appropriate for the type you're looking at. But I'm a little, like if you're looking at a bool, you should access the bool field here of this union, I'm guessing, if you're looking at a no return type. So each of these fields of this union or variants of this union is appropriate for one specific type, seemingly. Inferred tag union. So no Siam, does that mean that if is it possible for me to write some unsafe type confusion by accessing, for example, the bool field here? Well, these are all voids, but for accessing like the array field when what I'm actually looking at is a pointer, Like, can I just unsafely access any of these fields like I could in a C union? And do I have to like correctly determine that like this is for an array and then access the array field, or is this more like a Rust enum where like I can only, it seems like it's just untype safe, right? Like I have to know I'm looking at array and then I access the array field. That's what I'm guessing, kind of like in C. Just for a refresh, I don't know Zig very well. I've done some Zig programming. Yep, this is really feeling like I am not going to be able to figure this out on stream. But I'm still kind of having a little bit of fun poking through this. I know it's bad content though. Built-in type. That would be a union, not a union enum. So no sign, does that mean to figure out what this type is, I just kind of do a switch on it, just like a regular enum? So if I want to know what type I'm looking at, I just kind of switch on this type and then I follow, for example, the array match arm, switch arm. A Zig union is like a C union. A union enum is a tagged union. All right, so I do switch on this to figure out that it's an array. And what I'm looking at in these types are either pect structs or enums. I wonder if there's just like a method on this type that'll tell me the type width. But let's assume, so if I take a step back and remember the problem I'm trying to solve is that when I see a pect struct, I want to know what the width of that struct is, like sort of what the underlying integer representation of that struct is. So imagine we switch on this type and we see that it's a struct. So presumably struct and pect struct are covered under the same variant. And we, I was hoping that would go somewhere else. So if we look at a struct, type struct, layout, the layout seems like it might tell us where the, oh, no, that will tell us if it's packed. And presumably we're already doing something like that. Yeah, there's nothing here. Oh, backing integer. That's probably what we want to figure out the width. I'm wondering if I really want to try to solve this problem or not. It's not very important. Like if we solve it, it's just kind of for the sake of my own learning and curiosity. Sig release safe, insert a tag automatically even on the bare union. Gotcha. So when you do release safe, and I think Tiger Beetle always compiles and release safe. There's a bunch of other checks in Zig. Let's go back to the code real quick. Just look at what we got here. So no Siam, you've been saying repeatedly that this should be stood built-in type. But am I wrong in thinking I can just call at type info on that and get the stood built-in type? Are these two just redundant? I'm going to test that hypothesis. So I'm not going to use this at all. I'm just going to say let type info, let const type info equals at type info of type. But this type is a value. This is not a type. So maybe, well, it's calling type info on that right here. So I thought type, yeah, metaprogramming is so confusing. I thought type info had to be called in a type, but this is a value. This is a name of a value of a type. Maybe it works both ways. But can I just then replace type info here? Let's see, cargo build. Seemingly not. Oh, can't shadow and zig. Shoot, I hate that. Bindings, your unused function, unused function parameter. Can't not use something in zig. Used as an identifier without. I thought this was the way you say something is not used, but I might be mistaken. Switch layout back into, yeah, that looks something like that. Looks right. Oh, huh. So you don't even like declare this as a const. This is just a special syntax specifically for disregarding a name. That's interesting. Thanks, no Siam. I appreciate it a lot. No field name fields in union built-in type. Huh. So this type info is different from this. So this didn't work after I tested my hypothesis. What the heck is an any type? I'm kind of getting frustrated, y'all. Don't really get it. Type info. Just look at this error message real quick. There's no, so when the any type, so type info, the at type info intrinsic did give me a std built-in type, but that was not the same as this any type. Real quick, I'm just going to go look at the caller that's providing that type info. Emit enum info struct type info. Okay, this is something inside of the struct info. All right, so that any type is not actually the std built-in type info. It's already been extracted from the struct here. Emit enum. That any type, so it could be a struct type info or an enum type info. Kind of a mess. Kind of a mess. And then presumably this type info.fields is just doing kind of like a duck typing. Like this just happens to work whether you have this enum type info or the struct type info. Okay, I kind of get that. Yeah. The way that's what I think is working. So this any type could be either the variant inside std built-in type that represents a struct or the variant that represents an enum. And presumably they both happen to have this fields field. And so through the compile time duck typing, this just works because that field resolves. But there's kind of nothing in the type signature that says that whatever this is has a fields field. That's what I think is happening. There are types that do not have fields. Yeah, so I'm just going to leave that alone. It's kind of a mess. But on the other hand, if both of our struct and enum type descriptors have that, what was it, the layout field, if they both have a layout field, we can just duck type the access of that layout field. Let's go look real quick. This is a super yakshave. So here's the struct type. This has a layout field. And somewhere is going to be an enum type as well. No layout field. There's a tag type. Yeah. So the code path just has to be different. Yeah. I think I kind of more or less get what's going on here, and I don't love it. It's just kind of confusing. My preference would be to not have this passed in at all and to properly switch on this type to pull out the information. In particular, this is just kind of like hoping that a fields field exists on this thing. I don't remember if I wrote this or if that came directly from the C bindings we copied off of. Let's see, do I actually want to try to follow through on this? I think I kind of do. So let's just go here and say we don't need to do any of this. Just go revert. You can go revert that experiment. Yeah, I don't know if I'm going to keep any of this at all, but I'm learning stuff. Types that do not have fields. So what I want to try to do is I want to insert some kind of switch here to get the width of this type we're emitting. And it's going to change based on whether we're an enum or a packed struct. So I'm going to say let const typester equals something. And this is going to be challenging to figure out all the Zig syntax for this because I don't particularly know it. This is going to be type, actually at type info of type, and that's going to give us the union enum in Zig. Yeah, I saw that. No Siam. I'm going to crib off of it, but I am going to try to think through it. Yeah, I'm looking at it. I am going to try to think through it on my own, just for my own comprehension. It's interesting that you wrote dot at struct. I guess that makes sense. The variant is called struct, and that's a keyword. So we care about, but if we look at down here in this other code that already exists, this type info is dot capital struct. Zig type. We're passing Zig type in. Why would that be capital struct? I'm going to go back and peek at the docs one more time. All right, so this is the std built-in type at struct. Huh. So it must be a different thing than is being switched on. Let's go back to the code again. All right, so in this other code, there's a switch on the type info of this Zig type. Oh, wow. Thanks for the hint, no Siam. Okay, so this is a difference between the docs that I'm reading and the version of Zig we're using. The Zig master docs are on 0.14 and Tiger Beetle is on 0.13. I wonder if I can go back and just put a 0.13 here. Yes. Aha! Oh man, that's super confusing. Thank you, no Siam. All right, so this makes a lot more sense compared to what we're looking at. Huh. Wow, so the conventions here changed massively between versions. And this is the old version, and look how clean this looks. And this is the new version, and look how, yeah. I'm sure there's a rationale for it, but these docs look bad compared to the old docs. I guess the convention just changed that these variants need to be lowercase in 014. Hmm. Yeah, seems like it. No, Sam, do you know if all enum variants in 0.14 uh, have the convention of being lowercase named, or is that just specific to this, special built-in type? It doesn't matter much. Now we know how to proceed at least. Oh, I don't think I was showing my screen. 1.4 is going to be out on March 3rd, probably, which is very soon. Yeah, there's already a PR in the Tiger Beetle PR queue that does most of the conversion to 0.14. Okay, let's try to make a little progress here. And so I can just crib off of this code. So if we see a struct, we do one thing. If we see an enum, we do another thing. Else, we are just going to panic. So if we see a struct, now I'm going to go crib off of what you wrote to me in chat, no Siam. If it's a struct, all right, we're going to pull out that payload from the struct. So this is the stood built-in struct type right here. And we're going to do another switch on that. Switch on the layout. Okay, so here's our other switch statement right here. And if we see dot, let's go look at the docs again and see if 0.13 looks different. So here's our struct, layout, container layout. These are still lowercase. Okay. So if this is dot at packed, we're going to, and I'm going to try to make this all an expression, but I'm a little confused about what can and can't be an expression in Zig still. S dot backing integer, and we're assuming there is a backing integer. We're just going to fail if it's not, and that'll propagate automatically because we're returning a potential error in the return type of this function. But that's not actually going to give us a string. That's just going to give us a backing integer type, I think. I'm going to go back and look at the docs again. So if the container layout is packed, we actually don't even really need to look at that because this whole function is about packed integers. We can really just pull this out and assume this is going to be non-null. If it's not, then we're seeing something unexpected. This is going to give us another type. So in this expression, we can really just pull out a type and we can convert that to a string later. Let's try that. I'm going to go back over here. Again, I'm not sure if we're going to keep any of this. I'll call this backing type. And we don't even need to switch here. We're just going to assume that there is a backing type. And then if it's an enum, then and if it's an enum, we're going to go do something different. Let's go back and look at the docs again. So if it's an enum down here, there's just a tag type. This is all making sense. Type name of backing. Oh, thank you for the hint. So we can just ask the compiler to tell us the type name. Although that's going to be a Zig type name. I don't know if that's going to get us where we want to go. Tag type. I'm just going to see if this compiles. And of course, we're going to have to say, yeah, we're not using this. Okay, so that compiles. So we have the backing type. Ooh, now I'm going to say const rust backing type stir equals switch on backing type. And is backing type a type info? I don't think it is. I think it's a type. I think we need to say at type info of backing type. Thanks, Nissan. I really appreciate it. And so let's go to the docs and see again what the... I'm starting to get a hang of it. I'm starting to understand. Again, metaprogramming is just really confusing. It's always mind-boggling in every language, especially for me. I'm pretty limited in my cognitive capacity. Let's again look at what the type info is. And now these types should just be integer types. So it should be this int case here. Yeah. So presumably we're going to run into this int case here. It would be nice if there were just some like helper methods on here that could just do some of this stuff for us. But we're going to have to do another switch on this, it looks like, and then pull out this int. Stood meta. Yeah. I'm not going to go down that yakshave just now. I'm going to keep following this pattern we've got. So bits. So it'll tell us how many bits we've got and the signedness. I'm just going to do another switch here and pull this int out. WSL. So we're switching on the backing type and we're going to say int I, then have to do something here. And then else panic. Okay, so here we're going to have to do some kind of formatting with .i.bits. So I'm going to say constant bits. I don't need to assign it to a local, but i.bits is going to contain the number of bits in our integer. And we're just going to make assumptions about the signedness. Oh, I can assert. Assert i.signedness is equal to, and I've forgotten. I'm getting much better at switching back and forth between windows and changing the OBS scene. I haven't screwed up too bad today. So this int contains signedness, which is another enum. Signedness dot, so we can just say dot signed, unsigned. We're assuming these are all unsigned. Signedness dot unsigned to the code and say equals dot unsigned. I think that's correct. And then the thing we want to do is say stood. Right, how do I'm actually going to have to allocate a string to make this work. Unless we just do a switch on the bits because there's only a few cases. And then we create just pass back a static string, which seems like the easier thing to do here. Do a switch on i.bits. And probably there's only two cases that we're going to see, 32 or 16. And you say 32. It's going to be a rust u32. 16. Going to be a rust u16. And else. Again. No, Siam, is there a more idiomatic way to do this kind of like bug panic? Right now I'm just saying panic unexpected everywhere. But in Rust you might say unreachable. Okay, I did something. Undeclared identifier assert. This is not how you do an assert in Zig. How do you do an assert in Zig? That is how you do an assert. You got to import assert. Assert is a library thing. So I can say standard assert, stood debug assert. Compile error. Oh, Oh, compiler error. So I could say, this is all a comp time function. Is this comp time? I don't know. I don't even know. A lot of comp time stuff in this function. So you might just be able to say there's a compiler error. Okay, what am I doing wrong here? Unused local constant, of course. But this seems to otherwise compile. No. Value of type. All non-void values must be used. 102. Error value. Screen flashing. Brongulus is my... I don't even notice when my screen flashes. It like doing an annoying thing where I hit some keyboard and the whole screen flashes. Just kind of... I don't even see it. Error, values of type. Oh, I bet I'm not doing an expression thing right here. No, cyan, like this is not the proper syntax to return something. Yeah, returns a string to nothing. So I got to do like a break or something here, or remove this assert. Like I can put maybe a break label there. Where do I put the break label? So here I would say break, something like that. And maybe here, label the outer switch. And then this is a statement, not an expression. Let's see. 99. And this whole thing is, wait. Expected semicolon, line 99. I have a semicolon there. Expected semicolon after statement. Line 99, expected semicolon after statement. Is there anything else here? Not really. Semicolon, semicolon, semicolon. I don't see it. Maybe I've got the syntax. I always forget, like the label needs a colon in one spot and then the break label needs the colon in the other spot. And I always forget exactly what order those need to be in. But I think this is right. The compiler isn't really complaining about the colons. Break. I don't get it. I don't see it. Let's remove that semicolon and see what it says. Nothing new. Must be some other kind of syntax error in here that I am screwing up and the compiler is not liking it. That all looks right to me. I think all these are expression arms. I'm just removing label not found break. I'm just removing stuff and trying to get different error messages. I'm pretty confused right now. You know, the compiler's really not helping me. Switch, arm. These arms are allowed to end with commas, right? I don't get it. Let me just back up real quick. I'm going to checkpoint what I got here. Just completely change this. Just make this all an expression. Just to see what happens. It looks like it's, oh. Yeah, now I don't need this break anymore. And well, that really failed. Line 103. Line 103. Panic unexpected, line 103. I don't see that at line 103. I see that at line 104. So there may be other cases here. Let's see if there's an 8 case. I know this stream has really gotten into the weeds, just me learning Zig. But maybe that's exciting viewing. This stream is nominally about building a Rust client for Tiger Beetle. Hey, that worked. Okay, so there's a U8 case there. For some reason, the case that I had here, I could try to capture it, yeah. I still want to back up and try to understand why my break formulation here didn't work. So what I wanted to do, let's go all the way back. And we know there's a U8 case we have to cover. So this is now no longer an expression. It's just statements. And this should pass the value back up here. But the compiler does not like my syntax. I got semicolons everywhere. Maybe because I assume every arm can be different, like this can be like a statement arm. Maybe that's not true. But this is a divergent statement, so I would expect that to type check no matter what. Because it is appropriate in the Tiger Beetle code base to have that assert right there. Tiger Beetle uses a lot of asserts, so I hate to just give that up because I don't understand the syntax here. But the compiler is really not throwing me a bone. I'm just going to put a semicolon here and see what it thinks. Nothing. Maybe I don't put the label in the outer switch. Maybe I put it here. I don't know everywhere that a label is allowed, but well, Zig mode doesn't think it's allowed there. Maybe I put a label here. No, Zig really hates that. Maybe I put a label there. Oh, well, that at least passed the syntax. And you can see our good thing we put that assert there because our assert was wrong. So you can see our assert. Okay, multiple things I'm wondering about. This label worked fine right there. Did not work right there. Don't understand that. But then also this assert did fail. So apparently we are seeing either an enum or a packed struct that has assigned representation, which is pretty surprising. I would not expect that. I wonder if we can do some kind of debug print here to tell us exactly what this type info is. Let's see if we can, right here. And now I got to remember how to do a print of some kind. Debug print maybe. And this is going to be something, some kind of debug string. I'm going to need some help. Compile log. Okay, I'll try that. I've never used compile logs. So you're going to have to help me. At compile log. Can I just splat anything into compile log? Let's see if that does something. Oh, that does something. Here we go. Thank you, no Siam. So there is some type that we are generating that is signed 32 bits. I want to see more about this type. Let's go back and do the same thing, but at a higher level, right there. Type info of type. Oh gosh. Oh gosh. That's not readable. But it's this last case that is the weird case. I'll highlight it. It's an enum. Tag type is a cint. What is this thing? Fields are all elided. There's some enum that is a cint tag type. Let's see, if we print more, we're already printing the Rust name down here. Rust name. You can probably just print the Rust name as well. Right here. Let's see if, let's see what that prints. You know, it's not a string, it's just a array of U8, so it might not print anything useful to us. TB status. Oh, it was smart enough to. So TB status, wherever we're getting this definition from, has a very weird type. That's pretty darn surprising. Huh. So I'm going to go look up. We have this big list of types up here. All right, so TB status is defined not within Tiger Beetle. So it's not like a core Tiger Beetle type. This is a client type. So if we go look at TB client.zig, let's see if we can find TB status T. Interesting. Look at that. Why? That is. So I think basically the code gen for this is probably wrong for every client. Probably doesn't matter because it's not anywhere near filling up the address space of a 32-bit integer. But you can see here within TB client, they defined this particular enum as having a cint representation, not a cuint representation. It's interesting. There's all these little places around these bindings, this FFI, where things aren't fitting together perfectly, but also probably don't matter in practice. But it's a little, there's so much unsafety. Everything's unsafe at the FFI boundary. And there's all these little infidelities. But now that we have found that in the Rust bindings, we can fix it. Let's try to fix it. So this assert is wrong. So I wonder if we can switch on, we got a tuple here, and do a switch on both signedness and unsigned, or both unsignedness and the bits. I don't know the tuple syntax. Someone's probably going to have to help me again. But I'm going to pretend that we can say dot I dot signedness, I dot bits. And then here we could say, I'm sure this is going to be wrong, but we'll go back and fix it later. This is going to be dot unsigned and 32 dot unsigned 32 or 16. I'm going to go back to the log here. All right, thank you. Need a dot before those braces and see what combinations we have here. So almost everything is going to be unsigned except for this one 32-bit signed value. All right, so these tuple literals need a dot in front of them. So probably also there in the destructuring. So we've actually uncovered so many little interesting flaws in our C bindings generator that we could come back and do several streams just kind of cleaning that stuff up. It might be worth doing. Probably is worth doing. And then we have to have one more case for signed 32 bits. And this assertion is just wrong. And this is going to be a signed integer. Let's see how that goes. We're not actually using this anywhere though. Well, let's see if this runs at least. Switch on type struct. So it's not a tuple. Yes, of course, no, Sam. I should come back and generate all the functions too. But if I'm really going to get deep into the world of Tiger Beetle bindings, I'm going to have to go like learn how to build all of those clients. I'm going to have like a JDK and a Go install. You know, might be worth doing, but there's a lot of activation energy involved there. Right now, I'm just relying on CI to handle all those other languages for me. Okay, so it's not liking the switch on a struct, but I wasn't trying to make a struct. I was trying to make a tuple. Maybe there's something I can do slightly more clever here. I'm still not at all clear on the distinction between anonymous structs and tuples. Signedness. Switch on signedness. Unsigned. There's some kind of comp time error on the switch. Can you not switch on structs at all, or have I just done something foolish? Maybe I should just have two switch statements. We're already yakshaving so much, I'm going to go read some more docs. Let's go see if there's some examples of switch statements on compound types. That's not struct, switch. All right, this is not a switch on a struct. That is a switch on an enum. Tagged union, capture the fields of a tagged union. Maybe there's just no destructuring of structs. Doesn't seem like it. Oh, so zig tuples are just anonymous structs. Okay. And it seems like there's just no switching on structs. I'll change this a bit then. So instead of switching once, we'll switch twice. I don't think we need any of this logging anymore. Create a tagged union with every struct. I don't feel like that's worth the effort for this. So we'll switch on the bits first. And then there's only one case where there's a distinction. This is going to be 32. And then right here is just another switch. I.signedness. And here we can do an exhaustive switch. Say dot unsigned and dot signed. I'm going to hypothesize that this works. It does. I mean, it compiles. Okay, let's try to use it. So here, this is going to be that Rust name and Rust backing type stir. And then down here, I think this right here, we can replace. No, that is just the Rust name. This might be the whole thing. Yeah. We're just making a type alias for that backing type. Let's see what this does. This is not going to compile because now we're going to have type mismatches, but they're going to be correct types. You can see right there, there's one of those old mystery casts that we have figured out at this point. Yeah, all these old mystery casts. We should just be able to remove them. Ooh, there's a whole lot of changes here. Okay, I think we'll start in this conversions method. I'm going to go ahead and back up a little bit and get rid of that. And just kind of commit where we are because there's a whole lot of churn here that's going to happen. Check. Okay, so I think the first thing to do is go into this conversions. And remember, this is where a bunch of the C to Rust type conversions are. Let's just start here at the bottom and look at this one, 281. Expected U32, found U8. And I'm going to open our generated bindings, which are presumably all correct now. This packet status from U8. Huh. I bet this is a type def, and we should have like a TBC packet status T here, actually, not U8. TB packet status, capital TB packet status. Well, that is actually a U8 still. From U8 for packet status. Other as U3. Oh, this cast is no longer necessary because this is now declared correctly. So just remove that cast. And that should help us. And then 282, right here, this unknown V, probably packet status, this variant now probably contains a U32, but should be a U8 correctly. So I'm going to go up to lib packet status. Yep. So remember, this used to be, we used to think this was U32, but actually it's a U8. going to keep going. I'm going to ignore this, whatever this is, and keep looking through these conversions. And that's the easiest entry point here. 262. From U32 for status. So maybe status is not a U32. Right. So if we go back to lib and look at status, enum status is probably a U16 now, because all of these were naively U32s before, incorrectly. And this is probably a these are all U16s. This is probably supposed to be a U16. I'm kind of concerned about this actually. I want to make sure 263. Unknown. Expected a U16, found a U32. Maybe I'm wrong about this. Let's look at TB status. It's a U16. But other, oh, I just defined this incorrectly. That is a U16 as well. It's going to be like this for the next 10 minutes, y'all. Just fixing type errors. Let's see, how many do I have here? Not too bad. Not too bad. All right, let's go back and start at number 1 now. librs61. Create packet. This is calling one of those ugly generic methods, so it's going to be a little tough to understand. Op is a U32, but op is actually a U8. Let's go look at TB operation. TB operation is now just a U8. So if we go to fun create packet, this is a U8. Let's see how op is being used here. Operation op as U8 doesn't need to have a cast. That's probably it. That's it. Well, that's not too hard. Let's see if the test pass. I don't need to run. Hold on. There we go. Okay. That all worked. So we've kind of fixed a bug in the Tiger Beetle code gen just for Rust. And I assume that bug exists in other bindings generators. It does exist in the C bindings, and other languages reuse some of the C bindings. I feel good about that. We fixed a bug. It would be best if we come back later and fix it everywhere. I'm just going to reset again and make all that one commit, and this is probably going to be the it for today. I'm just going to package up this commit, push it to our PR, and then we'll call it a day. I'm going to reset to person Rust client, git add, fix type, I'm going to call this rework, fix type mismatches in Rust bindings generator. And I want to look at that diff real quick just to remember what we all did. And we learned a lot about compile time type reflection in Zig. That was very useful. And then these types all fit together much better now. And it's so simple, so easy. Great, that's great. Good fix. And we got to run format and Clippy and all these things again. Probably I should even go out to Tiger Beetle and run Tiger Beetle tidy. We didn't really change much Zig code today. I'll deal with that some other time. I think I can just push this though. Git push. And I'm going to go leave a comment on this about how this bug came from the C bindings generator on the PR, just to have some paper trail. But I'm not promising to actually fix anything there right now. But actually, I'm going to go put a to-do. Right now, we have a kind of temporary to-do list in our PR, in our bindings generator. I'm going to add this to that. Pack struct. Okay, we fixed this in Rust. So now I'm just indicating that's a problem in the C bindings. I'm just pin that. I'm going to force push. And now I'm going to go leave a comment. I pushed another commit that fixes incorrect types in the bindings. Incorrect types for enums and packed structs in the bindings generator. This bug comes from exists in the C generator as well, though it's kind of innocuous. I don't think there's any immediate potential for an actual bug there. Like all it involves, it causes extra casts. And sometimes those casts are narrowing casts, which means like if those enums grow to be some size or maybe use like a negative value in their variance, they could end up being correctly someday. Okay. Well, that ended up being a very productive day, actually. We made progress on the rework on our PR for the Tiger Beetle Rust client, and we learned some Zig. No Siam, I really appreciate all your help today. That was super useful having a buddy figure stuff out for me with all this Zig that I don't know. I'm going to try to come back more frequently. I know it's been a long time since my last stream. I'm going to try to come back and work on this project. I'm going to come try to work on this project more frequently. So next time we will do a little bit more rework on this PR, and we'll probably be doing that for at least another few streams. My name is Brian, Burson on GitHub, BRSON. My socials are there somewhere. I'll see y'all next time. Thank you so much.